1.08e negative 5. And hit enter, and I got two answers. Well, that's not very nice, but let's put them in there. X equals 3.67 times 10 to the negative 4 moles per liter. And the other X we have here is 2.54 times 10 to the negative 4 moles per liter. Now, this is so sad. They give us two answers, but there's only one correct answer. So we're going to have to go back over here and check out what we have for our x's here. Now we have 3 times 10 to the negative 4 here, 3 times 10 to the negative 4 here. And we have 3.67 times 10 to the negative 4 here, and 2.54 times 10 to the negative 4 here. Which one is a bad answer? Bad answer. Bad answer. That's that one. Why? Because it's bigger than the initial concentrations of iodine and bromine, which means we're going to end up with negative concentrations for equilibrium. That's just not happening. So we've got to use the 2.54 answer. So this is no good. This is what we're going to go with. So, since we're trying to find out concentrations at equilibrium of each one of these, the first one, the iodine and the bromine are going to have the same concentrations, and that is equal to 3 times 10 to the negative 4 moles per liter minus 2.54 times 10 to the negative 4 moles per liter. And that means then that if you subtract it in a calculator, you're going to get 4.6 times 10 to the negative 5 moles per liter. Now for the iodine bromide, that's equal to 2x there. And x we established is 2.54 times 10 to the negative 4. So the concentration of iodine bromide is 2 times 2.54 times 10 to the negative 4, which is equal to 5.08 times 10 to the negative 4 moles per liter. There are your three answers for that problem. A lot of moving parts here. So go through this a couple of times to make sure you got it down before you try the even number problem that corresponds to this. Or not. See if you got it right in the first try. That'd be kind of cool. This one, oh, holy, we got all kinds of things going on here. This is problem number 61, as you can see. And we're given 0.500 molar of PCl3 and of the Cl2. Divide the two out because it's in the 5-liter container. We get 0.100 molar of PCl3, 0.100 molar of chlorine, and we have no PCl5. So that's not at equilibrium. Obviously, this is our initial concentration, so there's going to be a change involved here, and a resultant equilibrium mixture that we are going to be asked to come up with. And I'm going to leave it in moles per liter because that's generally how these problems work. So every once in a while you see a problem that, well, what is it in moles? Well, you have to change the moles per liter back to moles because of how things multiply and divide out in your basic expression. So this is an important step, but I'm not going to go back to moles. I'm just going to leave it in moles per liter. So changes are going to occur because these are going to collide and decrease, and it's going to form this stuff over here. And the nice thing about this problem, as opposed to the last problem, is that all the coefficients are 1. So, if we're going to lose x here, we're going to lose x here. That's our change on the left side of the arrow. The right-hand side of the arrow, yep, I know. We're going to add x. So, can't believe that solid accident came out of it. My mom used to tell me, we lived in a lot of places. In my first 21 years of my life, I had 21 different addresses. And my mom told me that I had a mixture of accents when I lived in Windsor. Can you imagine a southern person with a don't you know accent? I had it. Like she said, when I got mad, guess which accent came out? Southern. Yeah. Spent a lot of years in Texas. All right, anyway, wonderful story, Kim. Well, thank you. All right, so the Kc is going to be equal to the concentration of PCl5 over the concentration of PCl3 times the concentration of Cl2. So we plug in these values, and the question marks become the sum of these values here. So this becomes, I'm just going to say 0.1 minus x. It means the same in the calculator. This is just getting 3 sig figs and groups. This is 0.1 minus x, and this is just plain x. So that's what's going to go in over here. So this is going to become then x on top, and we're going to get 0.1 minus x squared. Well, obviously it's 0.1 minus x times 0.1 minus x, just for the same reason of the last problem. You have to blow that thing out, unless you guys know how to multiply binomial squares, which you should, but I know your insecurities about math and all that stuff, so I'll do it the regular way. Well, my eyes while I do it. So this is the 49 equals x over. Now I'm going to forward this out, and then I'm going to rewrite till the x squared is first and the non-x is last. And I'm going to get x squared minus 0.2x plus 0.01. Now this is nice because I don't have to combine anything here. So all I have to do is go ahead and multiply by this by the 49. So both sides, we multiply by x squared minus 0.2x plus 0.01. Same thing here. X squared minus 0.2x plus 0.01. This cancels out here. Alright. So 49 times that is 49 x squared. 49 times that is a negative 9.8x. And then 49 times 0.01 is 0.49. And that's going to equal x. So now, what I'm going to do to solve this in the quadratic that we want to use in log form, I'm going to get rid of the x. So I'm going to add a negative x to both sides. So negative x here, negative x here. That gives me my 0 here. Now, remember, if it says negative x, it's actually an implied 1, so it's negative 9.8 plus the negative 1 is a negative 10.8. So this becomes 49x squared minus 10.8x plus 0.49. That means A is going to be equal to 49, B is equal to negative 10.8, and C is equal to 0.49. We'll punch that into my calculator. 49, negative 10.8. Don't forget that negative sign, or your calculator will just melt down right in your hand. I've seen it happen. It ain't pretty. 0.49. Now, gee whiz, we get 2 answers again. Oh, all right, so that's equals 0.157 moles per liter, and x is equal to 0.0639 moles per liter. So one of them is going to be legit, the other one is not, so let's go see what happened. Oh, goodness gracious here. All right, so 0.1 minus x is the equilibrium concentration, so it's bigger than 0.1, we can't use it. So that first one's no good. We get 0.0639. So now we got to come up with the concentrations. So that means PCl3 and Cl2 are both going to be concentration of PCl3 equal to concentration of CO2, 0.1 minus 0.0639 is equal to 0.0361 moles per liter. And then PCl5 concentration, according to the problem that we set up, is X. So that is 0.0639. I say 2. All right. Your practice problems. Pages 680, 687, problems 58, 60, and 62. Have fun!